All right, well, I found the problem, and I'm glad I did. It was actually rather easy. I haven't fixed it yet, but because I want to show you what I found. I just was sitting here scratching my head. There's absolutely no reason why this board would have a much higher video output than any other JAMA board. They should all be relatively the same. A lot of them have different onboard graphics where, you know, the image will be smaller or narrower or shifted more to the right than another board. You put in two different boards, they're in different locations on the screen. That's all fine, but as far as the video output being bright and contrasted, that should all be the same across the JAMA standard. There's no reason why this one would be so much brighter and more vibrant than any other game board. So just based off of that, I was going to put some resistors across the input for RGB and just kind of dumb down the signal with some resistors on the RGB lines. But while looking around for which pins I should put the resistors on, I found this right here. Toasty! I did not notice that. It was obviously this was in the machine and it was playing and working fine, so there was no reason to suspect a faulty component, but I did notice that. Nice and charged. So I'm going to replace that capacitor. I don't know if a power supply zapped it or what, but I'm going to change it out and check all the traces and all the components around it. It burned up and went vertical across this capacitor and then across this R352. So I'll clean all that up and I'll probably replace, I'm going to replace both of these capacitors and see what happens. So through the magic of video editing, I actually have I got a whole bunch of these bad UMK, or bad Wolf unit boards I should say. I got a bunch of these bad Wolf unit boards that I can steal these caps off of. They're all the same filter cap. And we'll put that on here and we'll see if it has the same output as the other boards now. So hopefully this will rescue and fix the project. And we can proceed from there. So let's get these removed and replaced, and we'll see what happens. And all changed out. You can see nice and clean now. New caps, good solder jobs, all courtesy of the hot air station. This thing, all these tools are a godsend. The soldering iron and the desoldering gun and the hot air station makes very quick work and very professional looking jobs when you got to do this kind of stuff. And here is the burned up one. Ouch. That's a bit charring. This one here I changed out just for good measure. So these are both changed, and now we need to just get the monitor back on the bench and fire it up, and we'll compare it now. Hopefully it should be good. I'll bet you that's it. If not, I'll have to go back to my idea of adding resistors onto the RGB lines here on the board. So let's test it out, see what we get. So I tried it off camera and it did not work, and in hindsight, of course it didn't work because this whole area over here is all part of the audio section. Now I have no explanation as to why the audio was working, because these caps are part of the audio circuit that run this area. So they're just filter caps, so I guess that's why the audio was working, because they're just filter caps to filter extra noise and stuff. But why it blew up I can't say. These obviously stayed intact when I powered it up. But this did not fix the issue, and in hindsight, of course, it didn't, because this is all audio over here. But my mad scientist, Dr. Frankenstein type of stuff here that's going on is, if you look, these are the three input filters for the, this is red, this is blue, and this one's green. It goes actually over to the back side of the board, because this pin is red, this pin is blue, and then behind red on this other side over here is the green pin. And that corresponds to this one here. So what these are just basically 0 ohm. I've already done some work to them, doing some testing off camera, and I'll show you the results here. But these are the little coil filters for the input. So if something came across the input that the board didn't like, these would open up or explode or blow. They're basically just act as fuses. And they're 0 ohm fuses, or 0 ohm coils, if you will. So if you actually take these out of the circuit, you have no red, no green, and no blue. So without these in the circuit, you have nothing. So I took this out of circuit, this one here for the green, and I added a potentiometer onto here, and I'm going to turn it up until I'm going to add resistance on the video circuit for the green. And I'm going to see if it actually makes the green go down. If it does, I'm going to set it to a good point of where the green should be, based off the other PCBs, and then measure what it reads. And then I'm going to add some surface mount resistors on take these three fuses out, because voltage always takes the path of least resistance. So even if I piggyback, let's say 1K ohm resistor on top of here, it's still going to read 0. So all these would have to go away, and I'll put, well, let's say it's 1K ohm. I'll put 1K ohm resistors in their place, and that should fix my problem. Again, this is something I've never come into before, or come across before. I've done 2 of these multi-MK cabinets, and the first one I did back in 2009 didn't have this problem. The one I did after that, I can't recall exactly when, it's been forever, that didn't have this problem. This is the first time I've ever ran into this problem. And I hear you screaming across your monitor or your phone now, well, what if it's the monitor? Well, it's not, because I took one of my U5000s and a U2000, and it does the exact same thing on those monitors. MK1, 2, and 3 are perfect, and MK4 is way overdriven, way brighter, contrast is bleeding, color's bleeding, the whole 9 yards. You put the other boards back in, no problem. So there's something going on here where all of the colors are being much higher voltage or much higher output than the other standard boards. No explanation, but this should fix the issue. So you'll see here, I've got this hooked up to the green input across the green filter input, and we'll turn this on, and I'll adjust that down, and we'll see how it affects it. So let me get the camera on the tripod, get set up, and we'll get this turned on and see what happens. Alright, so we're hooked back up, ready to go. So in theory, I should be able to turn this pot, and it should turn the green down, because I'm adding resistance to the video circuit on the green line, and that should decrease my green in theory. So let's turn this on, make sure it's still way overdriven. This is all still currently set for the other MK1, 2, 3 boards where the picture is fantastic and this is overdriven. So let's turn this on. Oops, sorry. And there you go. You can see this should all be black. All of this area that's white, everything should be black, and that's a good indication it's way overdriven. It's out of focus, and you can see the colors are bleeding. So let's take this and turn this down, and I'm going to turn this, and it should go down here. It's not turning yet. It's hard to do this with 2 fingers. There we go. Yay, it works. Look at that. Let's get something on the screen here. Actually, let's just reboot it here. Let's reboot it. Alright, let's turn this. Oh, gosh dang it. I'm touching it with my finger. I may have to just put this on the tripod. Let's just put this on the tripod. Okay, so now I'm going to turn this. Let's see what it does. Hey, look at that. I can make the green go away completely. That works perfect. Turn it back up. Yeah, look at that. That's with 0 resistance. Right about there is good. I'll reset it again. So you can see when I adjust that, the green goes down. So if I turn the green back up, right there, that should be perfect. So if all I have to do is replicate this, I need to test and see what that is reading, and I'll have to duplicate it for the red and the blue, and that should fix this problem, make it on par with the other boards. So stay tuned. I'll show you how I get this solved and how I get it resolved, and what the end result will be, and we'll test it one more time and see if it turns out to be good. Okay, let's see if we can get this resolved. So our measurement where the green was good, based off of our potentiometer here, we have Frankensteined in the circuit, is around 400 ohms. Let's just say 400 ohms. So in theory, I should be able to remove this coil and this coil for the, let's see, it was red and blue. And if I have a Wolf unit board, and if you notice, across the control inputs, there's a bunch of pull-down resistors here. And if I read these pull-down resistors, it reads 328. So very close. So what I'm going to do here is I'm going to remove the coils and whatnot from here and install these pull-down resistors, since they're close enough to 400, onto MK4, and we'll turn it on and see if it's close to... anything's better than how it was. Anything's better than how it was. So let's take this apart here first. And we'll zoom in as close as I can without going over, and I'll end up in the showcase. Okay. It's going to have to probably be... oh, I got greedy. There we go. Alright, let's fire up our hot air station. And we'll grab our tweezers. Here they are. And we should be able to simply just take these wires off by heating them up. There we go. Now, okay. Gone. Gone. Just as easy as that. Now what we'll do, this one here is for the sync. So it's green, red, blue, and sync. So if you ever have an MK4 that's not syncing, check to make sure that this isn't open. If this is open, you will not have any sync. So I've just found that out because I thought this was green. I thought it was red, blue, and green. So I found that out the hard way. I put it back on and I had my sync. It's actually red, blue, and green's over on this side. So, all right. Let's take that out of the way and set these over here in case I need them again. And let's take some of these pull-down resistors off of here. I don't care about burning this up, so we're not going to worry about that. Actually, you know what? Let's test to see... what are these here? These are 4.7K, so we don't want that. Yeah, these will have to come off. These are 328, so let's take these off of here. One, two, three. Just as easy as that. All right. Set these in place here. That should be okay. That should be okay. That should be okay. Just like that. Gotta have the right tool for the right job, and it makes it a lot easier. So now, oh, let's see what they read. Hopefully it wasn't a false alarm there, or what's a false reading while it was on the board. I should have measured them off the board, but let's see. They're also hot, so it may change the reading if they're hot. But we'll go ahead and just see what they read here. This one here, 335, fantastic. And 333 and 333. Perfect. I think this will fix my problem. Put that out of the way. Let's get some alcohol. Clean this up a bit. Okay. Alright, I think we're good. Let's check it out a bit closer here. Yep. Perfect. Oakley dokley. Let's see what that results in. Again, I have not touched any controls or any adjustments on the monitor, so you can join in the knowledge with me of if this works. Set this aside. Oh, also I noticed that this amplifier here has nothing to secure it. The screw's missing out of it, so I got a screw and a nut. So let's put that in here real quick. Alright. Okay. Fingers crossed. I'm confident here. Get all this back where it goes. Okay, one moment. Alright, here we go. Outstanding. It's still off with the white balance. There's still, the black area has a bit of a tint to it instead of being all black, but I'll take this. Look at that. It won't focus that. Yeah, that's not too bad. But all signs point to yes. Yeah, you can see it's still kind of, the white balance is still too high, but oh man, that is way better. Oh yeah, look at that. Perfect. Perfect. Outstanding.
Round one, fight.
I'll tell you right now, I can live with this. Fantastic. Let's change this out to MK1 just to make sure it's the 1 through 3 are still good. There we go. Let's see how this looks. And we'll skip past this. Oh man, awesome. It won't focus up. Yeah, there it goes. That is, I've never seen a monitor look this good. It's amazing. All right, guys. Well, there you have it. Crisis averted, problem solved, a little engineering, a little ingenuity, and we got it going. So I have no explanation, but adding those resistors onto the line fixed the problem. Focus up. There you go. Man, that looks good. All right. Just for the hell of it, let's put MK3 in here. MK1 and 2 are both on the T unit, so there's not going to be any difference regarding what that looks like. So let's throw 3 on here. I just can't get over how good it looks.
Round one, fight.
Man, that's awesome. All right. Let's toss number 4 back in just for the hell of it. Fantastic.
Retire. Round one, fight.
Yeah, it's not perfect, but it's far and away better than it was, and I will take it. So thanks for watching, and now that this crisis has been averted, we will proceed on with ordering parts, and stay tuned for, I guess, the part 4? I think part 4, so stay tuned.